Good evening, ladies and gentlemen, and welcome to the Community Hour once again. We've got a real interesting show for you this week. You know, we live in kind of a dry and forbidding climate here, but there is one thing that sustains life in the desert, and that's what we're going to talk about this evening. And the one thing that we all need, can't do without, as you can see in the background, it's water. And this evening, we're going to take an extensive view of the High Desert Water District. Yep. Here's your chance to learn all about the High Desert Water District. So the thing to do, go get yourself a nice cold glass of water, sit back and relax, and let's talk about the High Desert Water District. This evening, we're going to start out with a little introduction to a couple of people that are formidable in the water company. It's the general manager, Chuck Bryant, and the president of the board of directors of the High Desert Water Company, Bob Armstrong. So guys, why don't you come on in here? We'll see what we can enlighten the folks about the High Desert Water Company. Good evening, Bob. How are you?
Good, Bill. Yourself?
Good, good. Chuck?
Hi, Bill. How you doing?
Good. First of all, I'd like to say thanks for being here and letting us come into the water company. What we want to do here is I think that the water company is a stepping stone to economic development and something that we can't do and can't do without. And what we want to do is kind of show the people out there how we manage the water here and how we've created the water district and what you guys are going to do to help us create economic development through the water company in the future here. We have a percolation pond back here.
Finally.
Finally.
Finally. Yeah.
Yeah. And this is pond site number 6, I believe?
Yes.
What you guys refer to as site number 6? Mm-hmm. What about the percolation pond here? How much water do we use here, or how much water do we attract here, and where does it go, and how do we use it? Here's a microphone.
The maximum we can bring down through the pipeline is 30 acre feet a day.
30 acre feet.
That's right, and that's when we're kind of, acre feet. It represents 1 acre foot represents 326,000 gallons.
Whoa!
And that'll feed an average family, 3 families a year on 1 acre foot.
And we put how many through here?
Well, at the maximum, we're playing with the basins now to try to balance them out and see how much we can actually bring down. But the maximum we can bring down is 30 acre feet a day. And we can only bring about 330 days a year because the state does maintenance on their facilities, and we're getting the state water.
And when we say bring it in, where does this water come from?
Originates in Oroville, the Oroville Dam up north, and travels down, and we pick it up from Hesperia, and it comes 70 miles down the Morongo Basin pipeline to our regulating reservoir, which is in Yucca Valley. And then we have another 8 miles of pipeline bringing it down into Yucca Valley to this. This is the end of the line right here where we are today at Site 6.
We have 2 other percolation ponds in town?
Yes, they're Sites 7A and B, and they're in operation also.
Okay, probably by the end of the show today we'll visit one of those sites.
There, yes.
Yeah, all right, good, good. Well, Bob, maybe you could tell us here, why percolation? Why don't we just set up a big old filter and filter this water? Why do we percolate the water?
Well, Bill, primarily the management and the directors of the water district felt that at this time it wasn't economically feasible to treat the water. This was far less expensive to percolate it down in. You got the end result, and we just felt like for the people of the community to have to pay for a water treatment plant was too much to ask.
So what we're doing here is we're sinking the water into the ground. The ground is actually filtering the water, and then we're bringing the water back up through our wells.
We're just doing what nature naturally does. A little redundant, but we're just bringing the water in and letting it seep through the soil and purify itself before we pump it back out.
Okay. And is there any way to gauge right now how much of this water is coming back up in our wells?
Yes, we have engineering reports that tell us how the wells are responding. We have the valley mapped out in 3 sub-basins inside the Warren, what's considered the Warren Basin area here, and this particular sub-basin is showing favorably with the recharge of the water.
All right, so
the wells are rising.
All right, the wells are rising. We're getting more water in here.
Yes.
And basically what I'm interested in here is suppose we found a little factory out there, or a big factory, somebody that wanted to come to our community to employ the people. What we're going to show them here is that we have a water system in effect that's actually creating water, and the desert isn't a dry, parched place that some people think it is?
Well, that's a good question. I think that what the water district is trying to get done, and we've been trying to put out a lot of publicity about it, is by the turn of the century we hope to have a large what's the word? Reserve, thank you, of water. You know, it's so hard for people to understand. It's underground.
Yeah.
You know, if this was all above ground, you'd be playing on Lake Paris. But underground, we should have enough reserve water that water should not be an issue for us again, like it was in '89 and '90.
So we're creating a, let's say, a confidence in the area through importing water. And
I think that the people of the Morongo Valley should hold their heads high over voting for the bond issue to bring the pipeline water down. And, you know, we've got Northern California water here, which should thrill us. The people in Northern California aren't thrilled. But we have an adequate supply of water to supply the growth, and the board of directors and the management of the water district are concerned and have a goal to meet what the town of Yucca Valley is anticipating their growth potential to be.
All right. And let's see, in the background out here, we see a couple of our water district employees enjoying a day in the sun out there, fishing in the pond. Is that what they're doing?
Well, that's a lot of times what they like to do with their day is just relax and catch some rays out here.
Yeah, that's it exactly.
Interestingly enough, one of the things that the water district is looking at is doing some work with the town and being able to use the ponds partially in the year for some recreational activities. Electronic, radio-controlled boats.
Yeah.
Those types of things have been talked about to allow people to use it. It's pretty to look at.
Yeah, it's a great thing, and I think almost everybody in town, when you first said percolation pond, that was the vision that came to them, is that fishing and sitting around the bank.
Right.
Pond, bullfrogs and all that.
Yeah, do a frog gigging contest. Now there's a thought we haven't come out with.
There you go. Yeah.
Well, what are these guys doing in the boat out here?
Well, they're not playing. That's part of the maintenance. We must have control of. We have these midges. They look like mosquitoes. They are not mosquitoes. They don't bite. They're not a health hazard. They're just a nuisance.
Yeah.
And no, so we do have a chemical that's approved by the health department that we do broadcast in the lake, and they also. We're starting to do some what we call algae control, because you're going to get get water and it's raw water and the sunlight together. You're going to end up getting algae.
Something grows in
that
there.
affects the percolation rate, so we have to keep that cut down too. You know, you want going back, if I could, I wanted to show you what the board of directors has approved.
Let me hold this up here so Bob can get a shot of it.
Yeah.
While you tell us what it is.
The yellow portion is what we anticipated, what our share of the Morongo Basin pipeline is, which is over 4,000 acre feet. The blue area is what the board of directors has approved for the purchase up through the year 2000. And along with that, we have a conjunctive use agreement with the Mojave Water Agency. The fuchsia color is actually what the High Desert Water District will be bringing in over the year 2000. And the conjunctive use agreement with the Mojave Water Agency is this color here. And it'll show that in the year 2000, we're going to have about 25,000 acre feet stored and banked, and for the next drought that comes along. It will sustain the High Desert Water District customers for a period of 3 or 4, maybe even 5 years, if we don't get any additional water in during a drought. So the planning for the future is something that the board has been doing, and it's to make sure that the people within our community are assured they're going to have water in the future.
And anybody that might be interested in coming here.
You bet.
Okay,
you bet.
that's an important one. That's kind of one reason why I wanted to come here today and investigate the water district. There's a lot of people out there that just because they pay the bill, they feel they have the right to scream and holler at you. But what we want to do today is give them a good look at really what goes on behind the scenes in the water company.
You bet.
Now, not only percolation ponds, but we have wells out here. We have how many wells in the area?
17.
17 wells. Maybe we could wrap up the camera here and travel down to one of our well sites and see the other end. Okay. Sure. Well, good. Let's do that, folks. Let's take a little trip down to the well site here. What well site are we going to? Do we know?
9 West.
9 West? Okay. Here we go. Next time you see us, we'll be at the well site. Okay, well, here we are at the site, and a little something I want to point out to you here. A little later in the show, we're going to talk about water awareness. Now, what I'd like to talk to you about here is water unawareness. How aware are you of how much water you use and what water means to you? Well, here's what you do. Have a little test. Go out to your water meter, turn the water off at your house and see how long it takes you before you get out there and turn it back on. If you're not aware of how much water you're using, that'll really surprise you. Try turning your water off, see how long you'll last. You won't last long at all, I guarantee you. Well, let's see, here we are at a well site, and here's Marty Stockstill. Marty, you're the assistant general manager of operations for the water company.
That's correct.
What does all that big title mean?
Well, I'm primarily responsible just for the operation, the entire operation of the district, oversee the other. I do have supervisors and crew leaders that generally keep everything running out here pretty well.
So you're kind of the contact point between the administrative, the office, and the guys in the field?
Yes.
Okay, great. And what is this contraption here? Where are we, and what is this?
Currently located at our well facility 9 West, and that's what this is. It's a well. This is all the above ground pumping, including the motor, which actually runs the well to pump the water out.
So basically this is one of those round stone fixtures with a little roof with a bucket on a rope that goes down, and we're used to seeing, but
a little more sophisticated.
A little more sophisticated
modern
here.
than that,
Yeah,
correct.
That's
but
it.
essentially the same principle.
Well, how does this well work? I mean, what's the principle here?
Principle here is that the well, in this particular well, the motor is located above ground, sits above the well, then it is connected to a shaft that goes all the way down to the, on this particular case, where the bowls or the pump is located at approximately 600 feet below us.
Whoa.
And it's all connected through a shaft, comes up through a column, what we call the pumps. The motor comes on, turns the pump on the bottom, essentially boosts the water up to the ground level here. Currently at this particular well, water level is around 400 feet down, so we have about 200 feet of water over the pump, actually.
600 feet deep this well is that?
The actual well in itself, casing in the bottom of the hole, is right at 800 feet deep.
Oh, 800 feet. And how is that in terms of well? Is that relatively deep, shallow?
It's for, this area is relatively average, about average. We have in between that will go down 600 feet, the bottom of the well, to 1,000 feet. In some cases, 1,200 feet, we go down, essentially find bedrock.
When the water, you pump it up out of here, 800 feet to the bottom, 400 feet to the water, you have to pump it all the way to the surface, and then where does it go?
From that, as soon as it gets up in here, it enters the pipeline. This discharge pipeline goes through a meter, enters right into the distribution system. Our distribution system is all the pipeline throughout the entire system. And what it does whenever the well turns on, puts water into the system, and what people do not use from that being, it goes to a reservoir for there it's contained for use when the well is not being run.
So this is a pretty intricate system. It's not just the pipe from the well to your house and the little tap. There's a lot of things in between.
A lot of things in between. We have to, in some cases, we have to reduce the pressure. Areas we have to boost it up. Air vac, a lot of information.
What about the maintenance on this well? I know people that have their own wells, the part of the country I came from, every once in a while lightning would strike the well and darn pump down at the bottom of the hole, it'd fry like that. You ever have those kind of things happen to you?
We do have it within the electrical panel on this, where if we're going to get a lightning strike, it's generally at the power source, is that we have protection in there for that to stop the lightning before it gets the motor, to burn the motor up in this case.
Oh, all right. Good way to save people a little money, a little preventive maintenance there.
Right, and general maintenance, a little lubrication. We do once a year, we do an efficiency test to see how efficient the motor and the pump are, actually.
What about the cost for one of these wells? What does it cost to put one of these wells in here?
To drill the well, this well here, exact cost on it, but we could say between $80,000 to $150,000 just to drill the well. And that provides the hole, the casing, everything. And then we actually have to equip it. That's with the pump, the motor assembly, and above ground pump, piping. And that can run in, up to $60,000, $80,000, depending on the size horsepower motor and the amount of water you want to pump through it.
So we're talking about a pretty expensive piece of equipment here, really, and it's well worth it, though, I guess, when we get water out of the ground.
Correct.
Like we stated, without the water, if we turned their water off out there, they'd be screaming in a minute, huh?
Wouldn't take long.
Wouldn't take long at all.
We get calls occasionally.
Yeah, that's it. How many more of these wells are in the system here to back this one up?
To back this one up, we have an additional 16 wells. This one alone would not supply our need. We run them in combination. All 16 wells never run, or all 17 never run at the same time.
Yeah.
We'll alternate them from primary wells.
Let's talk about telemetry. I was a little on the dumb side this morning. I looked up telemetry in the dictionary before I came here to see what was going on with telemetry. So when I ask you about telemetry, I'd know what I was talking about. And in Webster's dictionary, telemetry is defined as the art of reading a telemeter. I think he wasn't doing much better than I was this morning.
No, not telemetry. In our case, telemetry is, that's what it's doing. This motor will sense a level in a reservoir, and based on that water level through a radio wave is what sends the level to this one. It will turn this well on automatically whenever the tanks need the water.
So this thing is self-operating here. You just go away, leave it alone, check it out every once in a while. It senses how much water we're using, how much we need, and it pumps the needed water out of the ground?
Correct.
And then where does it send it?
From here, like I say, it goes in distribution system, primarily goes to a reservoir though, because we could not run the system just off of wells. We have to have the tanks that the water is stored into to meet need when the wells aren't running and to maintain a constant static pressure in the system.
All right, I guess before the show's over, we're going to visit one of those tank sites. That's going to be pretty interesting. You know what? I noticed there's a little building here next to us, and on the door it says chlorine.
Correct.
This is also a chlorination station here?
All of our well sites are equipped with either a permanent chlorine station like this or a portable one for injection when we have to, in the case of an emergency, earthquake if we need to, and also in our case where we chlorinate 3 months out of each year, which is mandated by the state that we do that we inject chlorine in the system to assure that we don't have a bacteria problem within our system, primarily.
And that's, so basically you chlorinate through each well site here?
At each well. The months that we chlorinate, we'll be beginning here again in June, we'll chlorinate. We assign specific wells and we alternate the wells that we do because we want to operate them differently, give them some use, but we will inject chlorine into the system at a ratio of 5 parts per million, or excuse me, 0.5 parts per million.
0.5
That's a half of a part per million water. In other words, a half a drop to a million drops of water.
Minute amount.
A minute amount of chlorine. Sole purpose primarily of that is we build the system up with a chlorine residual throughout the system of 0.5 parts per million of chlorine, and it's an indicator. It lets us know if there's chlorine in there or nothing else as far as bacteria is going to survive in that atmosphere. So it indicates to us, it cleans the system, and it's a definite indicator that we will not have or do not have bacteria in the system.
So there's really not enough of it in there to really, you know, taste or distinguish or anything like that. The tap water that you get out of home, you can't tell it's in there, but it's in there for a safeguard. Safeguard,
but people can, and some people are more susceptible both to the taste and odor, but it is definitely something that most people can, they will notice it, both in, not so much taste, but as in the odor of it. But you can smell it in that quantities. A normal pool runs 2 parts per million. Is what a normal pool would, and you get that smell, but this is down to a 0.5 parts per million.
So it's in there for safety, it's in there to keep everything going well. And I guess what happens is, how do the breaks in our pipelines affect that? Is that part of the reason that we're chlorinating?
It's part of it. The actual reason for us continuously chlorinating on a 3 months out of the year rather than on an as-need basis, if something were to come up. A couple years ago, the district was in violation actually of a coliform rule, which is a very stringent rule for how much coliform bacteria can show up in any 1 year of sampling. We sample roughly, take about 20 samples per week, and in a 1 year period, 3 of those sampling weeks we had coliform bacteria in excess of what the state will accept. So for that, they mandated that we develop a program or plan whereby we would assure that wouldn't happen again. We presented to the state health a plan whereby we would chlorinate 3 months out of the year. They accepted that plan, and that's what we're following currently.
Okay, so the rest of the year, other than these 3 months, there's basically no chlorine or no additives to the water. It's just good old natural H2O that comes right out of the ground?
Right out of the ground.
Filtered by good old Mother Earth from the percolation pond?
Exactly.
Or the aquifer?
Correct.
Okay, well, let's see. What we need to do, I guess, is, are you going to go with us up to the tank station?
Yes.
So we can take a look at one of our water tanks.
See where all this water goes.
Yeah, that's pretty interesting.
Great.
Okay, folks, well, what we'll do here is we'll leave the well site. A pretty interesting site it is, too, and we'll take a trip on up to one of our tank sites and see what's going on up there. And I need to ask you this question. Have you run out and turned your water back on yet? It won't be long, don't worry. Okay, We'll see you at the tank station. Thanks, Marty.
Thanks, Bill.
Okay, well, here we are at one of our tank sites here. Marty's graciously consented to show us around one of these tanks. Pretty interesting site, one of these tanks, huh?
Yeah, this particular one's contain 2,225,000 gallons when it's full.
Wow, that's a lot of water. Well, let's take a walk inside and
Sure.
see what we can figure out with this thing.
Great.
Okay, well, let's see. What we're interested in here is this big old tank and how it works. What is all this stuff here?
What we have here at the well site that we just left actually pumps to this tank. To the tank and in the system, as I explained, we're at the well site. And then from this tank, we have people, obviously you can see, that are higher up than this tank, and people are fed from gravity out of the tank. So it goes to this tank, and then tank at a higher elevation will take the water from this one, gets a signal to these pumps. You have 3 different booster stations here, and they will pump the water up to a higher elevation to serve the people at higher elevation.
Right. So we're kind of taking the pressure off the well pump down there by just pumping it to here.
Correct.
And then we're using these pumps to go from here to higher elevations for people that live above the tank site.
Exactly.
Something pretty interesting that you were talking about when we first walked up here were these little fire hydrant looking things here. And the reason for those?
Yeah, they're not here for fire protection. All of our new tank sites or booster sites, we equip them with in the event that we have power outage, could be an earthquake or just a long power outage, we can actually bring our portable diesel pumper up here, hook fire hoses to these pumps, and if water is needed to boost up to the higher elevation, we can actually do it by that means.
Backup system.
Backup system.
Backup system. The water company is inundated with backup systems, it looks like.
Yeah, I'd say...
No way we're going to run out of water.
Right. Unless the, good enough earthquake can do it.
Well, look at the size of this thing. This thing is massive. It's big. What was the capacity of this thing again?
Okay, this reservoir is the largest one in our system tank. It is 2.25 million gallons, 2,250,000 gallons.
And is this tank full right now? And
currently, no, it's just a little over half full. The indicator target indicates that, and then also through telemetry we can monitor the tank level in here. But so we got a little over, probably about 1.5 million gallons in there right now.
It's roughly half full?
Correct.
All right. Well, let's take a walk over by this thing and take a look at it. This thing is amazing. I can't believe how big this thing is. And it's easy to see the outside of this tank. I mean, here we are, the outside of the tank. It looks all nice and new and shiny and well painted and all that stuff, but what about the inside?
Yeah, this tank was built in '91, so it's relatively holds up well on the outside. After 1 year of completion, we'll go in and inspect it, and also we go on a program whereby we have the diver come out and do a dive inspection. The interior of this tank is coated with a super tank coating, and water is very corrosive. This tank is steel, made out of steel, so any failures in that coating in there will lead to a rusting of the steel and deterioration of the tank. And that's quite a bit of surface area to go in there and inspect, and we do want to cover all the interior. Also, the roof area is very susceptible to corrosion because it's a mixture of water and air, so a very corrosive atmosphere in there. It has to be inspected.
Okay, divers?
Divers, yes.
Deep sea divers?
Deep sea divers, certified deep sea divers.
Or in this case, deep tank divers?
Deep tank divers, correct.
All right, well that's pretty interesting, and they've already been here.
They've been here, yes.
We need to take a look at some of these guys.
We have been on store at the office, tanks, videos, and books on photos from the inside, the actual video of the inside.
So we actually know what the inside of this thing looks like. Now, let's talk about something else here that is pretty prevalent in our area, and that's earthquakes. The ground's always shaking here. Do you guys have some kind of protective system for this tank or the water that's in it, or the system in general?
Yes, we do. Actually, 5 of our reservoirs were targeted for hazard mitigation funds that we could use, and we applied for funds whereby they provide 50% of the funding if we would provide some type of earthquake preventive maintenance or something in the event of an earthquake. We could save the water in the tank, not necessarily the tank, because the tanks are designed for earthquake standards for AWWA. But right here in this device is a seismic sensor, and that seismic sensor is essentially hooked directly to the valve that goes in, that controls the flow of water in or out of this tank. In the event of a earthquake, right now we preliminarily have these set at a magnitude of 6 if we were having an earthquake magnitude 6, this will sense that and it will start closing the valve down. It will not, this is a 12-inch line, it won't close it all the way down, but it will close it down far enough to allow the water that's in this tank to be saved in case of major breaks in the system, in the main system, where it won't take this tank and completely drain it, so we'd have water available.
Another backup system.
Backup system.
Backup,
Exactly,
backup, that's it. And let's see, you mentioned that there's a 12-inch pipeline under this thing.
Correct.
Now, what about, we've seen the well, we've seen the tank, we've seen the ponds. What connects all these things together? How do we get water from here to there and back again?
Well, the district is roughly 50 square miles, and within that, not all those square miles contain mines, but probably the major backbone of the system is the wells and the tanks, but what people don't see, and that's all the piping under the system. We have piping ranging in size from the 12-inch main down to 2-inch water mains in some of the older areas. But that's the infrastructure underneath that the people don't see and that is in constant need of repair and or maintenance, be it the valves.
So what we're seeing here little by little is that it's an enormous cost just to be able to turn the tap on and have water come out in your house.
It's not all that simple out here. And,
yeah,
we
it sure isn't. It's
daily.
interesting too. This is interesting stuff here, the old water company. Something that we take extremely for granted. We drive down Old Woman Springs Road and see the little office building there, and we think that's the water company.
No, it's a 24-hour day job. Although the field crew work 5 days a week, on a normal job, they're always on call 100% of the time.
Yep, we see them out there patching the pipes all over.
Correct.
And let's see, I think you have a project going on in the west end of town right now. We're replacing or putting new pipes in. What are we doing there?
It's replacement with new pipes. Areas down there where the undersized pipes, where we're getting prevalently a lot of leaks, we're going in and putting new water mains in the streets there.
Okay, maybe we could take a trip down there and take a look in the hole, see those guys down in there putting the pipe together?
You bet.
Okay, that's it. Okay, folks, well, we're going to leave the tank site here. Pretty interesting stuff. Big old giant water tank right here. And what we're going to do is go down and take a look in the hole and see where we're putting new pipe in, and you can see what the new pipe is all about. Now, the question is, have you turned your water back on yet? If you had turned your water off when I told you to at the beginning of this show, you'd be pulling your hair out right now, folks. And just remember that the next time you call up the water company and scream and holler at that poor lady on the other end of the phone, okay? We'll see you in the pipe hole. Bye. Okay, well, here we are out here on the corner of, let's see, where are we? Elk and Onaga.
Correct.
And we're laying pipe out here along this street, new pipeline. Well, what we kind of want to do is take a look around here and everything else, and what I'd like to do, Marty, is say thanks a lot for showing us around to this point. The information you gave us has been great with all the tanks and wells and everything. And
You're welcome, Bill.
okay.
Next, I'd like to introduce Eli Shigley. He's my operations supervisor, and just in case he does take you close to a hole, you may need that. And good luck. I got lots to do.
Okay,
Thanks.
back to work. Thanks, Marty. Hi, Eli. How are you?
Fine, doing
Good,
okay.
good. Well, this is a little cheating. I've known you for quite a while,
Yeah, it's
actually.
been a while.
Not
It's
just
been a
from
while.
the water company. Yep, that's it. Well, what are we doing here on the corner of Elk and Onaga?
Well, we've got pipeline replacement going for our new capital improvement project. We're going to be currently they're replacing they're placing 12-inch PVC pipe. And let's go get a closer look if you want.
Okay, well, before we get down in there, the hole, maybe we need to discuss a couple of things like, why are we putting this pipeline in here?
Well, basically, we need to upgrade all the 2- and 3-inch pipe that's servicing this entire area out here. All the mains and stuff right now are currently located in the easements, making meter reading real difficult, making all kinds of things real difficult.
So this is just going to improve the system all around. The size of the pipe's going to be bigger?
Yeah, size
More
of the pipe,
water pressure?
More water flow.
More water flow.
Yeah, there's
okay.
definitely a difference between pressure and flow, but yeah,
Okay,
more water
well,
flow.
We don't understand that pressure and flow
that's
stuff
okay.
here, but and what about the size? You said this is a 12-inch pipeline that we're putting in?
Yeah, this is 12-inch PVC that they're installing here.
Okay, and we're replacing 3- and 4-inch pipe, stuff like that?
Exactly.
Okay, great. And about that pipe that we're replacing, how long's that been in there approximately? Do you know?
It'd really be hard to say in this particular area.
Long time?
Yeah, I think Yucca Water Limited originally did this portion of town in the early 50s.
Wow.
I couldn't be sure, but it's pretty old stuff.
You know, when I was doing the research on this show and stuff, I never realized how many water companies there are around here.
Well, there's a few.
There were quite a few water companies.
Yeah, there definitely
and
was.
a lot of them have been taken over. Well, let's see, how deep are we burying this pipe up there?
Currently, this pipe's going in with 36 inches of cover.
So we're about 3 feet deep to the top of the pipeline.
Exactly, to the
All
top
right.
of the pipeline.
And the cost of this project? Do we have any idea what this is costing us?
$870,000.
And that's just for this area, or all the pipeline that we're talking about completing?
That's all the pipeline that's in this capital improvement. That's 21,000 feet of 8-inch pipe and 5,400 feet of 12-inch.
Okay. So, again, what does this mean to the people that live in these houses along this pipeline? What benefit are they going to get from the new pipeline coming in?
Well, they're going to get an increase of water or fire protection. They're going to get an increase in water quality. With the old steel pipes and stuff, you got rust and other things in there that cause turbidity, color of water. They're going to have easier access to their water meters. They're going to get us out of the alleys in the middle of the night, waking them up when we're fixing leaks.
Well, that's probably the one they're most interested in right there.
There's several benefits.
All right. And before we go down and look in one of these holes and see these guys actually laying this pipe, which I think is going to be pretty interesting, how long is this project going to take? How long are these people going to be inundated with pipeline installation?
This project's supposed to terminate in mid-July.
Mid-July of this year?
Yeah.
So how are we doing? Are we on schedule?
Yeah, we're right on schedule to what they had anticipated. The schedule they gave me at the beginning of the project said they were going to start on Onaga Trail Monday morning, and bang, they were here.
Okay, and one more time, what's your position or your title with the water company?
I'm the operations supervisor.
You're the operations supervisor. So basically, you're the guy that comes out here and makes sure everything's going right?
I get a chance to check on it on a regular basis.
Okay, so you're in touch with the workers. You're the go-between, like between Marty's position and the worker in the field out here?
Yeah, for informal items, they
Okay, yep. So you're the guy basically that's making sure that we get our money's worth out here, that nobody's just throwing a piece of pipe in the ground without hooking it together and that kind of stuff.
Yeah,
quality control, could we say that?
Kinda.
Okay,
Kinda.
good. Okay, well, let's take a little trip down there and see if we can get hit in the head with one of these steam shelters. No, we won't.
Yeah.
That's what this is for.
That's what that's for.
Okay, folks, here we go into the depths of the water company. Okay, well, 3 feet. Seems like a pretty big hole for 3 feet, huh?
Yeah, well, you got to get enough pipe in there, and you got to get people in there, and
yep, all that stuff. Here's the end of the pipeline here. What's this pipe made of?
This is polyvinyl chloride, otherwise known as PVC.
PVC. So this is the same stuff as that little white stuff that you see running around people's yard, except it's bigger and thicker?
Yeah, the chemical is the same. The process for putting it together is different. There's no glue that's used on this pipe. It all slips together with a ring-tight seal.
Uh-huh.
And then
rubber gasket on the end of these,
yep.
Is that what we're saying?
Yeah, rubber gasket, and you'll see here they're just going to put one of these pieces together here in just a second.
Okay. And
they just soap up the end of it. Each piece of pipe is marked. In the bell, there's a little rubber gasket.
Uh-huh.
And you'll see with the backhoe, they'll just push it into place. And basically what they'll do is they'll stop right there on that little
all right,
black
so
mark.
we use the backhoe to dig the hole.
Yeah.
And we also use it to push the pipe together.
Yep.
Here we are, and this guy, oh yeah,
there you go.
The pipe slips in there.
That's how it goes together.
That's it. All right. Pretty ingenious, the guy that invented that pipe, huh?
Oh, I'm sure he's a millionaire by now.
Something interesting that you said to me, there's a little piece of wire going to go in with that pipe?
Yeah, that's for location so that so we have ability to hook up to it so we can trace the water main, because there's nothing metallic in there other than that piece of wire.
All right, so the same equipment with this pipe and that little piece of wire, you don't have to buy new equipment to trace the pipe. It's still the same old metal detecting stuff. Detects that little wire.
Yep.
Now you said something pretty interesting to me is that one of the benefits of this pipe is water quality.
Yeah.
So this pipe is going to preserve the quality of the water from the time it comes out of the tank or out of the well?
Well, what it's intended to do, and obviously not being made out of steel so it doesn't rust, you're going to get the normal, building up and so on and so forth inside the water main, but you're not going to end up with the flakes that pop off and the rust and particles and stuff going through the water main, clogging up the little areators when you get ready to get a drink or so on and so forth.
All right. Well, take a look down the pipeline this way. It looks pretty impressive down that way. We see this guy down here. He's using water to install a water pipe.
Yeah.
What's he doing down there?
That process is jetting. As you notice, they slough off backfill on top of the pipe there, and then he takes the water and basically jets it up underneath the pipeline so that we get a complete support zone for the pipe. Aids in compaction and so on and so forth.
And that's pretty important in earthquake country, that the pipe be supported all the way around
It needs to be supported equally so we don't have undue pressure in one certain area.
All right, rattle around. And And one more thing I noticed, there's equipment. You can see equipment running around down there. I see a flagman on each end of this, so the water company's doing all that it possibly can to make sure the safety of the citizens is taken into consideration here while we're doing this construction.
There's been a lot of consideration gone into the customers. Unfortunately, they're going to be a little bit inconvenienced while the construction's going on in their zone and stuff. The company that's doing the installation, though, is very conscientious about it. They make sure that traffic ways and stuff is left open as much as possible.
Okay. Well, I guess we've seen about everything there is to see about a hole in the ground. It's pretty interesting, though, even though it is just a hole in the ground. That was pretty interesting, the way the pipe went together. Now, another little thing I'd like to touch on here, as long as I've got you here, the way I see it, or the way I understand it, you're the backbone of the water company out here in the field, huh? Is that it? Don't be modest now. You can tell us you're the backbone of the water company.
I guess I get to oversee all the backbone of the water company.
All right, good. That's great. And how long have you worked for the water company?
I'm working on 16 years.
Whoa, 16 years?
Yep.
So you're a hometown boy? You were born and raised in this town?
Yep.
Came to work for the water company?
Yep.
Good thing for you it was?
Yeah, the water district's been good to me.
All right,
Been good for me.
Actually, I think the water district's been good to all of us, whether we work for them or just get water out of the tap.
That's true.
But it's kind of interesting to me that you're a hometown person here and you grew up in this town and you went to work for a public utility, and you know it's been a good thing for you. That's something that I really like to see hometown boys.
I agree.
Do
Absolutely
well, as
agree.
said, and thank the water company for everything that we got going around here. Okay, well, I think our next stop is going to be down and talk to the lady that really does the hard work. She collects the money from across the counter.
Yes.
She's in the danger zone down there.
She's in the danger zone. That's why she's behind the glass.
All right. Well, anyway, we'll go down and talk to her. Eli, I want to thank you a lot for talking to us today. It's been great here.
No problem.
Thanks for showing us around. And I guess nothing else to say but keep up the good work.
Okay.
All right. Thanks.
Hey, thank you.
Okay, well, by golly, you're getting a little idea now of what it takes to put water into the sink when you wash dishes. It's a pretty complicated issue here. It's pretty costly, too. You're starting to see a little bit about how big an operation this is and what it takes to back up the fact that when you turn the spigot on in your sink, water comes out. Good water, quality water, and easily accessible. Now, before we go inside and talk to the people that actually take your money across the counter, we're going to introduce you to a gentleman here. His name is Mike Hawley. Hi, Mike. How are you today?
Glad to meet you, Bill.
Good, good. And Mike, what you do is water awareness for the water company?
Yes, we put on a program for the customers for water awareness and household water saving conservation program.
So what we're saying here is that I'm sitting in a house somewhere in Yucca Valley on the High Desert Water District system, and it seems to me that maybe my bill is a little more than it should be. Maybe there's a leak, maybe I'm wasting water somewhere. And what I do is contact the water company?
Yes.
And then what happens?
Well, they set up an appointment and they schedule me to come out to see you. I come out there at a given time. We start out, generally the first phase of the program is to take the customer out to the water meter itself. We start at the water meter. I show them how to turn off the water main in case they have an emergency water situation where they need to get the water off fast. I show them how to read the meter. I explain a little tattletale device we have, a little red triangle there.
So if you shut all the water in your house off and this little red triangle is still moving, you have a water leak somewhere.
That means there is some water moving somewhere in that system.
No water being used, this thing should be stopped.
Completely static.
Something interesting about this meter is that it reads just like the odometer on a car.
Yes, it does.
So you don't have to figure out all the little dials and all the little numbers that used to be on the old meters.
No, it's fairly simple to read.
User-friendly here.
User-friendly.
You can check out your own water usage.
Absolutely.
Okay, so you come to my house, you show me the meter, you show me what's going on, how to tell if my water's being used, and then what happens?
Well, then we start inside the house generally. We go through all of the faucets and fixtures, looking for leaks, and put blue dye tablets down in their toilet tanks to see if, in fact, they have a little slow leak that is running down in the bowl and down into their septic tank. While all this is being done and the blue dye is working, I'm outside. I go through their irrigation systems. I look for leaks, for systems as far as, spray versus maybe drip systems and basins and things like that.
So you give them ideas on how to upgrade their sprinkling system for the most effective use of water on the outside in plants.
That's correct.
And what about the type of plants that they use out there? Do you also have a list of water plants that conserve water?
Yes, we have a list of about 4 pages of plants, shrubs, and trees that are conducive to the high desert area.
Oh, that's good. So, and how do we go about, suppose we just want to know, we're planting a few plants around our house and we just want to know, is there a way just to get that particular information?
Definitely. They can just come into the office and it's on the wall or posted. They can take a copy.
So all the backup paperwork that we're talking about here can be obtained right in the building here?
All the information that I provide during the audit is available in the office.
So I decided that maybe I have a leak in my house and I call the water company and I'm scared to death because I know this is going to cost me a fortune to have you come out to my house, huh?
Absolutely not. It's
half a fortune.
Free service provided by the water district to the customer in hopes that they can conserve water and, of course, save money.
Free service. It's a free service. Is that what you said, a free service?
Yes, absolutely free.
Oh, all right. So there's no cost to the customer out there. You're just going to come and take a look at it.
Yes.
Show us what you do. Interest us a little bit in water awareness.
Sit down and we'll talk about retrofitting, the benefits of retrofitting to low flow water devices, water saving devices.
And retrofitting, what are we talking about there?
Retrofitting would be installing the little low flow shower heads that take it from 10 gallons a minute down to 2.5 gallons a minute, converting a 5-gallon toilet down to a 1.6 gallon per flush system, installing flow restrictors on their bathroom sinks, kitchen sinks, etc.
And when we say flow restrictors, you know, I'm one of those guys that like to get in there and crank that shower on as far as it'll go and stay in there for an hour, you know. But when we're talking about flow restrictors, we're not talking about an efficiency level here. We're just talking about something that cuts down the usage of water.
Cuts down the flow of the water through that
Doesn't have anything to do with the pressure or the type of shower that you have?
The volume will be reduced from 10 gallons to a minute to 2.5 gallons a minute. So you're going to feel, you know, it's not going to be a pulsating, heart-beating shower. It's going to be soothing.
Something that's conducive to our desert environment.
Yes.
All right.
You can take a 10-minute shower and save 75% of the water.
Okay. Well, Mike, we want to thank you a lot, and we want to tell the folks out there to remember, have Mike come out and tell you all about the water meter, tell you how to read the water meter, tell you how to tell if you have leaks out there, generally. And Mike will also come in your house free of any charge. You call the water company here to set up an appointment?
Just call the office here at
and what do we ask for when we call here?
A Household Awareness Water Program.
365
8333.
365-8333. Okay, folks, call the water company. Be water aware. And remember, we told you at the beginning of the show that you were probably water unaware. Have you turned your water back on yet? I bet you have. Can't go. How long do you think they can go without water around here?
Oh, not very long.
Not very long at all. Okay, well, Mike, thanks a lot for the information.
Thank you,
Bill. It's a pleasure meeting you. Folks, call Mike. Get in touch with Mike. He'll show you how to save money on your water bill. Now, let's go inside and see where you deposit the money you bring here. Well, we've taken a look at the unfamiliar parts of the High Desert Water District, and now we're in here to some place that's probably a little more familiar to most of you, and this is the office of the High Desert Water District on Old Woman Springs Road, right at the bottom of the hill as you go up out of town. And with us in the office today, Michelle England. Michelle is the lady that customer service?
That's correct.
Customer service. Hi, Michelle. How are you today?
Good, thank you.
Good. Well, let's see. You're the lady that sits in here behind the desk when people come in the door to pay their water bill. You are the water company, period.
That is correct.
To them. You're what they see in the water company, and I guess you represent all their problems. Is that it? How about it? Do a lot of the people out there come in with problems that aren't really problems, that they just need a little explanation of the system?
Sure. A lot of people would like to have explanation for their water bill. On the bill it shows the water charge and also the debt service. A lot of people question those charges. The water charge includes the demand charge and also the amount of consumption that they're paying for the water. The debt service includes the pipeline charges, which is for the Morongo Basin pipeline, the extension from the east end of Yucca Valley to the recharge ponds and the ponds. And the west end area residents also have the safe drinking water bond loan charge that's assessed for improvements in the West End area only.
Well, before we came in here to talk to you, we've had a pretty extensive look at the water company. We've been to wells and tanks and pipe installation, and I mean, it's a pretty expensive deal here. So really, the charges that you see on the bill, although they may seem extravagant for what little bit of water comes out of your tap, but really there's quite an operation going on here.
There sure is.
Yeah, there sure is. I was really impressed with the operation today. It's been fun. We've had a good time. So that kind of, all the charges that are on your bill kind of include, well, not kind of, but do include all these other services that go on that the people don't see when they walk in the door here and confront you.
That is correct, yes.
Right. And there is another way to kind of cut your water bill for some people in the community. It's called low-income credit.
Right, we do have the low-income credit program, and that applies to customers that have an annual income that does not exceed $15,045 per year. So they can come in and fill out an application, provide us with proof of income, and then we'll go ahead and process the application.
And that particular number is for a household with 2 people in it?
1 to 2 people.
1 to 2 people. So, and you have all the information here in the office. If there's 3 or 4 or 5 or 6 people in there, they can come
call
in
us.
Yeah, and get information on that. And what about the process for paying your bill? There's a regimented
Sure. What a person needs to do is they need to, once they get their bill, there's a billing date at the top of the bill. And if the bill isn't paid within 20 days, they will be sent a reminder bill letting them know that the bill hasn't been paid. If it hasn't been paid within 30 days, they will receive a delinquency charge on the account, which is usually $10 for accounts below $100 or 10% of the past due amount for accounts that are above $100. And after 35 days, if the bill still isn't paid, they'll receive a door hanger. And finally, the 40th day, they will have their property locked off if the bill isn't paid.
Okay. So you do have a way of working with people that just might find themselves a little short this month, or at the time they can come in and give you a percentage, and this is the way the system works?
Yeah, we can work with the customers as long as they get in contact with us here in the customer service office. That is correct.
Yeah, okay, I understand that one. A lot of people just sit out there and stew, and when the stew's done, they yell because it's burnt.
That's correct.
Yeah, that's a normal thing that happens. Let's see, we talked to people in the water company who tell us about the retrofit program. Maybe you could explain a little bit about that to us.
We do have the 90-4 retrofitting requirement that is a district resolution. What this is all of the residences in the town of Yucca Valley do need to eventually be retrofitted, which is the installation of the low-flow toilets, low-flow shower heads, and the sink restrictors, and this is for conservation measures.
And when does this take place?
We will flag an account if it hasn't been certified by our district. We will flag it once the account changes names, and we will see that it hasn't been certified, and we will send a letter out after the account has changed names to let the new tenants or owners know that the property needs to be inspected.
Okay, so basically if you're building a home, it has to be low flow installation put in it, or if you buy a home or office or a business, something like that?
All accounts in Yucca Valley. The ultimate goal is to have everything retrofitted.
Okay. And what about new people that come in? If I came in to build a house or something, what kind of information do I need to bring here to open an account with the High Desert Water District?
If you were to come in to sign up for service, you would need to bring either a rental agreement or a proof of ownership. You would also be required to pay a $3.95 account setup fee. In a lot of cases, we require a $75 deposit, and you would need picture ID.
Okay. And that would get you new water service. About how long does it take to get service?
Usually if you come in the day before, we can get it on for you the next day, provided that it's not on a weekend.
1 day service. You can't beat that. Okay, let's see. They can get information here at the office, and maybe we could give out the telephone number of the office here?
That is correct. Our phone number here is 619-365-8333.
Okay, and that'll put you right in contact with the representative, Michelle England, the representative of the water company.
Yes.
So when people come in and talk to you, They're all bent out of shape because some squirrel just chewed a hole in their irrigation system. It's not your fault.
Oh, I haven't heard that one before.
Okay, well, great. Well, gee, Michelle, thanks a lot for giving us the information.
You're welcome.
It was nice to meet you, and I guess I'll see you in a couple of days when I come through the door to pay my water bill. Okay, well, that's about the conclusion of our show tonight. We're going to have a couple of statements here from some people that we met along the way. It's been a really interesting visit to the water company. We've learned a lot about the workings of the water company, water awareness, and just a lot of things that happen behind the fact that you turn on the faucet and the water comes out. Here we are by the percolation pond at the bottom of Old Woman Springs Road, and again, the people that got us started in this deal here, Chuck Bryant, Bob Armstrong. We want to say, first of all, thanks a lot for letting us come down and look through the water company as in-depth as we did. It was really interesting to me. There was a couple of things that I learned along the way that was really interesting. One of them, the Turtle Awareness Program.
Yes, during the construction of the Morongo Basin Pipeline and the pipeline extension, anybody that came on the site where the construction was going on had to go through a tortoise awareness program that's put on, and they had to have an orange sticker, as you had on the back of your helmet in one of the spots here, to show that they went through it. So if one of the people that look for those kinds of things came along, they'd see that orange and know that that person was approved and could be on the property.
Oh, all right, so it's training for the environment.
You bet.
All right. Anything along the way that you guys came across that you'd like to talk to us about now?
Well, while you were looking at other sites and stuff, I was doing something else, and what we did, we had an individual from the Department of Water Resources down, and we selected a site for what they call a CEMAS station, which is the California Irrigation Management Information System. And we're going to be putting that in on district property, and we're going to be managing it, and then it will help the large water users, like for parks and golf courses and large irrigation areas, control the water they use. And that the CEMAS station gathers weather data, and that would automatically adjust the systems, their irrigation systems, so the water that they're putting out is all that's needed and not wasted.
All right.
So that was happening while you were doing the show.
All right. Well, we're glad to see something was happening while we were here. As usual, something always is happening at the water company. But basically what I get out of that one is that you're as much concerned in the export of water as you are in the import of water. Where the water goes once we get it here is pretty important to you.
Exactly. It's conservation is the big thing in the state of California, not just in Yucca Valley. If the people in the 1970s during that drought were as aware of water use as they are now, and with all the education we have going and all the conservation programs, we wouldn't have had the major problems that we had during the 80s and early 90s.
All right.
And I would say the people in Yucca Valley within the High Desert Water District are doing an excellent job with their conservation, and we urge them to continue that.
Good, good. Bob, something you'd like to talk to the folks about?
Bill, basically, just to kind of take off on that, I think conservation is an issue that will not die, and it's an important issue to this community. As we look at what the town is feeding us for the build out of the community, we're going to be able to get there by using conservation and using good management and water importation into our valley. Basically, I just want to again say thank you for coming down and taking a look at us. I hope people can tell by the direction of the board of directors and the staff and management that the High Desert Water District is a well-run business, and that we're trying to respond to our customers' needs.
And folks, I'd like to just add to that is they can't respond to your needs unless you come forward in an intelligent and civil manner. Go to the water board meetings, talk to the director, talk to the president, talk to the general manager, talk to the people that you've seen in this little program today. Get in touch with your water company. If you have an idea, I'm sure that the water company is more than willing to sit down and listen to your idea, and if it's an applicable idea, it could be put in force.
I would like to add, if you're going to come to the water board meetings, we enjoy fresh made chocolate chip cookies.
Okay, chocolate chip cookies. All right, they're partial to chocolate chip cookies, folks. Don't forget that.
And I think we could probably be bought, with fresh brownies or chocolate
brownies.
Chip cookies.
Okay, so next time you go to pay your water bill, stuff a chocolate chip cookie under that window, and you'll be out. No, don't do that. Okay, well, keep in touch with your water company. There are people from your hometown doing something to benefit you. And like I said in the beginning, I think that the High Desert Water District is a big stepping stone to economic development, improvement of our community. And the way I see it here, they're trying hard to do what's good for us. Thanks a lot, Chuck.
Thank you,
Thanks
Bill.
for
Appreciate
having
it
us
very
here.
much.
It's been fun. And
Thank you,
Bob,
Bill.
thank you very
Enjoyed
much.
it.
Okay. Bye, folks. We'll see you next time in another place in Yucca Valley or the Morongo Basin.